Okay, my friends, you had a chance to try this on your own a few minutes ago, and what I would recommend is that you pause the video right here so you have a chance to check whether or not your substitutions and your calculations were correct for the quadratic formula and whether or not your factoring was correct here. These solutions are actually exactly the same. -5/8 is equivalent to -0.625. And that intercept, because it's negative, is over here to the left of the origin. That would be before the ball got thrown from the treehouse. We're not worried about this intercept. What we're looking for is this one that has a positive x value. And so that would have been when t = 1. So at 1 second, that would have been where Alex caught the ball. Moving on to the next example. Have you ever been to a carnival or a fair or something like that where you saw people who swung the hammer and hit the platform and then a weight goes up and then comes back down, and if it goes all the way up, it hits a bell? Well, even if you haven't seen this in real life, you may have seen it in a movie or something like that. And this is the equation that models the path of the weight as it travels up and down. T is the time in seconds, and h is the height above where it begins here at the platform. And so it says, if the weight reaches 14 feet, so that would be at the top up here, if it reaches 14 feet, then you win a prize. So they want to know, do you win a prize? So how does this 14 relate to this equation? Well, 14 feet is the height above the ground. So I am going to substitute the 14 in for h of t. And then I ask myself, how do I want to solve this? Do I want to solve this by technology? Do I want to solve it by quadratic formula or factoring? Or I have another method that we didn't mention in the previous example. The reason why we didn't mention solving by inverses here is because this is a standard form equation right here. And I don't want to solve by inverses if I see two terms that have a t in it. However, if I have only one t that I'm looking at in this equation, then inverses would be the best way to solve. So I want to subtract 15 from both sides. -1 equals -60 times t minus 0.5 squared. I am not going to distribute this -60 because distribution is not an inverse. I am not going to apply this exponent. I have to undo things when I'm solving by inverses. This -60 is being multiplied by this expression. The inverse of multiplication is division. I'm not going to worry about what the decimal approximation of 1/60 is at this point in time. Now I have to undo a power of 2. The inverse of a power of 2 is to square root. And now when I do the square root of 1/60, using my calculator, of course, I don't know these things by heart, I'm just going to round to 3 decimal places, good enough. And then the square and the square root, those are inverses, so now I just have t minus 0.5. But wait. Remember, when we use the square root power, not only do we get a positive root, but we also get a negative root as well. So I'm going to put that one over here, -0.129 equals t minus 0.5. And I have to solve for both. I want to add 0.5 to both sides here. In this case, t would equal 0.371. And here, I want to add 0.5 to both sides. And in this case, t would equal 0.629. Why does t have two solutions that make sense? Because this weight, maybe 14 feet, the bell would be about right there, but the actual height of the carnival game would be a little bit higher than that. And so as the weight traveled up, it would hit the 14 feet at this time, and then it would hit it again on its way back down. So the answer to do you win a prize is yes. You hit the 14 feet on the way up and on the way back down.